In this video we continue with the chain rule, and you notice that all four of these problems are some kind of radical. So with radicals we're going to rewrite them first with rational exponents. So for example, problem 11 we'll simply rewrite as 5 minus t to the 1/2 power. Then the derivative f prime of t will simply be 1/2 times 5 minus t to the negative 1/2 power. Then we'll multiply by the derivative of the inside function, which is negative 1. You always have to remember that. Ending up with negative 1 over 2 times the square root of 5 minus t. With problem 12, we'll also begin by rewriting. We'll get 9 minus 4x quantity to the 1/2 power. The derivative of that, very similar to number 11, we'll call that g prime of x, and that will equal 1/2 times 9 minus 4x to the negative 1/2 power. Then times the derivative of the inside function is just negative 4. Simplifying, that would be negative 4 divided by 2 times the square root of 9 minus 4x. And that'll do it for that one. Let's look at problem number 13. That would be rewritten as 6x squared plus 1 to the 1/3 power. So the derivative of y equals the cube root of 6x squared plus 1 would be y prime. We'd bring down the 1/3, reduce the exponent by 1, and leave the inside alone. Then we'll multiply by the derivative of the inside function, which will be 12x. So we'll have 12x in the numerator, divided by 3 times 6x squared plus 1 to the 2/3, and we can cancel the 12 and 3 to get 4. So we'd get 4x over the quantity 6x squared plus 1 to the 2/3 power. With number 14 we have the square root of x squared minus 2x plus 1, and we'll rewrite that. So it's rewritten as quantity x squared minus 2x plus 1 to the 1/2 power. And since that's g of x, the derivative will be g prime of x. We'll do the power rule on the rational exponent. So we'll bring down the 1/2, then reduce the exponent to negative 1/2, leave the inside alone, multiply by the derivative of the inside, which is 2x minus 2, then rewrite 2x minus 2 over 2 times the square root of x squared minus 2x plus 1. Now we can do just a little bit more here by factoring a 2 out from the numerator and canceling that with the denominator. So when we do that, we cancel those 2's there and finally end up with x minus 1 over the square root of x squared minus 2x plus 1. And that'll do it for these four problems.